And that's what the homework is for. Let's talk through some examples. Normally I'd say you do, but without the computer, it'd be hard for you to do it. So let's do it together. Let's talk through it. Okay. So, this problem. What do you have? You have, what's the data value? Is 1.75 a data value? No. It's a z-score. And what is it that we want? We want probability. So how are we going to do that? So norm s dist or use stat disk. Okay. So oops. Okay. So, but again, first draw the picture. So we draw the picture. And what do we mark off? 0 is in the middle for z. And what else do we mark off? 1.75. And what else do we mark off? Shade to the what? I'm still hearing both. Yes, why is it the left? Less than. Okay. So now we can use Excel norm s dist. Z-score is 1.75. Enter 0.9599. Is that your answer? Yes. This is 0.9599, and in particular 0.9599 is your answer. And also, looking at the picture, is it reasonable that the area that we've shaded is 0.9599? Yeah. Yeah, that's reasonable. Now, next, find the probability that z is greater than 1.75. What do we do? Exactly. Just to get us in good habits, I'm going to quickly fill a picture in. Of course, it looks almost the same. There's just one difference. Exactly. Shade to the right. So if we're doing this from scratch, we would get 0.9599, but that's not what we're looking for. 1 minus 0.9599, and that's 0.0401. Yeah, Edward.
Would you still want to do it minus 1.75 to 3.34? Like this is good stuff.
You could do that, yes. As long as you keep track and understand what you're doing, yes. But again, in case you mess up, in case you lose track of what you're doing, that's why the picture is so helpful. Because if you lose track of what you're doing and you plug something in, you get 0.9599. In the second problem, could 0.9599 possibly be the answer? There's no way. That doesn't make any sense. But yeah, if you want to use that shortcut, yes. Okay. If mu is 38 and sigma is 5, find the z-score of 31. So first of all, what do we have? Okay, right. So we just say that mean and standard deviation are just sort of things we know on the side. What value are we starting with? 31, and what kind of value is that? Is that a z-score? No. It's the data value, which is x. And what is it that we want to find? We want to find the z-score. So if we have x and we want a z, how do we do that? Right track, yeah. X equals what? Sigma. Right. Okay. So this is, well, mu was 38, z, oh wait, I flipped it around, sorry. We want z, crikey. So, z equals, right? Okay. Z equals what? Okay. So this is what? What are these numbers? 31 over 5. Okay. That's negative 7 over 5. So it's negative 1.4. Next. What is the male height for z equals 2? So again, what is it that we have? We have a z-score. What is it that we want? Data value, which is x. So, what do I write? X equals, and what does x equal? Right, the thing I just wrote 10 seconds ago. Okay. And the mean 68, the z-score is 2, and the sigma is 2. 68 plus 4, 72. In particular, since this is a data value, it's 72 inches. So again, as you're doing these problems, it's going to be really helpful to keep in mind where you are on the chart. Where you are, where you're trying to go. So again, I would say to start, use the chart. But once you're a pro, you'll know where to go. Alright. Any questions so far? Alright. Let's do a couple of slightly fancier problems. So, what about this one? What is it that we have? Sorry? We have z-scores. And what is it that we're trying to find? We're trying to find probabilities. Exactly. So, how do we do this? What's the first thing to do? Draw a picture. So, how do I mark the picture? Okay, what goes in the middle? 0 for z. And what else do I mark? Right here, 1.14. And right here, 2.59. What else should we mark off? And where do we shade the area? This is a between question. So shade between. Okay. So now to find this between area, what do we need to do? Subtract what? What's the, yes. So what is the next thing we need to do? Yes, we need to find the areas. Because if you subtract the z-scores, you'll just get another z-score. And is that going to help you find this area? No. Okay. We need to find the area values. Once we have the area values, so we need to find this area value and this area value. And once we have the area values, what do we do with those? We subtract. The bigger thing, take away the smaller thing, gives you what's left. Okay. So, how do we find those area values? Okay. Actually, I want to give us some practice using StatDisk. Let's use StatDisk. Take a look at that. So, StatDisk. Analysis, probability distribution, normal distribution. So what do we type in? Okay. 1.14. And what do we need from here? Area to the left, which is? Okay. So we should get used to using 4 decimal places. So the 4 decimal places, what is it? Yeah. 0.8729. Because you have to round it. So this one is 0.8729. And then we need to do which one? Alright. 2.59. And what do we need from here? Area to the left, which is 0.9952. And now we subtract. And that gives you 0.12. Okay. 23. Yeah. That's like that. Okay. And that's the answer. Next, we're going to do this problem, and this problem really ties together everything that we've been doing. Alright. Find the probability that a man is between 70.5 inches and 73.2 inches. So how do we do this? What's the first step? Draw a picture. Next, we mark stuff off. What do we mark off? 0 in the middle for Z. What else? 68's in the middle for what? For X. Alright. Now what else do we mark off? 70.5. And where does that go? Yeah. So 70.5 is here. And what else? And then 73.2 is right there. Now what else do we mark off? Shade where? Yeah, shade between. Yes. So that's just the question. Now we got to find the answer. So the first thing we do, exactly what Chastity said, we have to find these areas. So how do we find these areas? Okay. Norm S dist of what? Norm S dist wants what? Wants a z-score. Sorry? Okay. So you can be very clever and use norm dist, and I'm going to do that second. But yeah, if you want to use norm S dist, or if you want to use stat disk, you have to find the z-score. Or in this case, you have to find both the z-scores. So let's get to work. How do we find the first z-score, or one z-score? Right. So we know z equals x minus mu over sigma. So what's one z-score? There you go. And that's 2.5 over 2. And that's 1.25. So I now know something, so I'm going to fill that back in on the picture. The z-score for that is 1.25. Next. Exactly. Got to find the other z-score, 73.2 minus 68 over 2. And that's 5.2 over 2. That's 2.6. I now know that, so I'm going to fill that in on the picture as well. Now that we know the z-score, what can we do? Find the areas using either Excel or StatDisk. I'll go back to Excel for this one. Equals norm S dist of z-score. What's my z-score? 1.25. So that one is 0.8944. And we also need the area to the left of 2.6. So equals norm S dist of 2.6. And that is 0.9953. Oops. And so what we need is to subtract 0.9953 minus 0.8944, and that gives 0.1009. And that's the answer, and let me just top it off by labeling that on the picture. It's the middle area. And there you go. So notice how that last problem really called in almost everything that we know how to do. Not everything, but almost. And of course, Edward, I think it was you that you made a good point that once again we can skip over the finding the z-score step by just using, in this case, it would be norm dist. So yeah, you can do that if you want. Any questions? Okay. One little fact that you'll need for dealing with the textbook and doing homework. Sometimes it'll ask, is this unusual? So the textbook defines unusual to be something with a probability of less than 0.05. That. So that's all. Alright. So, quick recap. Everything we talked about today was this. And of course also dealing with the notation and the word problems. But everything comes down to this. If you're given a data value, how do you find a probability? Or if you're given a probability, how do you find a z-score? Etc., etc., etc. Okay? That's it.